Hi everybody, and welcome to a bonus lecture on doing truth trees inside propositional logic. So I've been asked to say a little bit about how you use some of these new connectives that are showing up inside your problem sets and your assignments and how you deal with them inside a truth tree. And now the particular case I'm going to be looking at is a case where you've got a kind of set of rules that you haven't been introduced to before. So these are rules that aren't the standard rules for the conjunction, the disjunction, the conditional, the biconditional, and the double negation, or the negations of those, and I'm going to show you how to apply it. So here's the particular rule that I'm going to be looking at. So here we've got alpha and beta like this. So we've got two different rules, and the rule for the negated case is just this. And then the rule for the unnegated case is this. Okay, so first I'll just tell you what these rules are saying, and then I'll show you how to apply it. So what this first rule is saying is that whatever alpha and beta are, and you can put in whatever proposition you want, when this whole thing is negated with this connective inside, you tick it off and it's a column rule, and under it you write alpha and then you write beta. So for instance, if you've got something like this, then what you're going to do is you're going to tick that off and you're going to write C and D. And in this case, the C is the alpha and the D is the beta. And over here, if you've got something like E, arrow, F, and then you've got this crossed circle to a G, like that, and the C here, we don't have a negation right out the front, you're going to tick this off, and on the left-hand side, you're going to have the negation of E, arrow F, and on the right-hand side, you're going to have the negation of G. So in this case, the thing on the left-hand side is playing the role of alpha up in this rule, and in this case, the thing on the right-hand side is playing the role of beta up in that rule. And that's the same for any of the rules that we have. They're framed in terms of alpha and beta, and the alpha and beta can just stand proxy for any proposition you want. And so long as you're dealing with the proposition using the rule, then you're going to deal with it correctly. So the sort of long and short of it is that nothing really that new is happening here. It's just that you've got some new rules for a connective that you haven't encountered for. So what I'm going to do is I'm just going to put up a random tree, and I'm going to solve that tree where it will require me to solve a couple of these different instances of this new connective. So I'm going to do an argument. So let me just put up some random argument. There's one premise. There's my second premise, and now my conclusion is this. Okay, so now I'm going to solve this tree step by step. And what I'm going to do is I'm going to apply those rules for the unnegated circle with a cross through it, and then a rule for the negated circle with cross through it. Let's make this one a negated one so that we get some experience in doing that. I've used A's and B's. There's nothing special about A's and B's. Anything that you use can stand in for the alphas and betas in the previous rules. Okay, so let's do this. So the very first thing I'm going to do is I'm going to negate the conclusion, because that's what I do. I'm testing it for validity. In order to test an argument for validity, you have to negate the conclusion first. And then what I'm going to do is I'm going to look for any column rules that I can do first. One of the useful tips that I can give you about doing trees inside propositional logic, or indeed any logic, is that you try and do the column rules first, because that's going to prevent the branching of your tree too much. So I know that the rule for this is a column rule. And by column rule, I mean there's no branch. I just write one thing after another underneath it in a column. And the column rule, remember for this, was just that when this thing is false, then this thing underneath it is true, and this thing underneath it is true. So it's going to be not B and then A. And that's just following that same rule that I laid down in the previous slide. Now what I'm going to do is I'm going to do this top proposition. And you'll notice that I'm not doing the propositions in the order that they're written. I'm choosing my own ordering to do them in. And you're allowed to do that, at least with propositional logic. Okay, and now that I've broken that one down, I can see I've got an A and a not A here, and that's going to close. And so now I've got this proposition and this proposition left to deal with. First thing I'm going to do is I'm going to do this biconditional here. So the negated biconditional, on one side you have A and then not B or A, and on the other side you have not A, and then B or A, like that. So the two sides have to have different truth values. Now, I'm going to do this negated disjunction. The negated disjunction, when the disjunction is false, then you get both sides of the disjunction being false underneath it. It's a column rule. I've got A and I've got not A there, so that closes. Now I come over here, I do this disjunction. That's going to branch. I'm going to get B on one side, A on the other side. That A and that not A are going to close. That B and that not B are going to close. All of the branches have closed, and so this tree is valid. So you can see that that new connective that I added in didn't really make much of a difference. All I had to do was just treat it like the other connectives in the following sense. I keep the rule for that connective in mind, and then I just apply it like I'm applying the other rules, and I just carry forward the entire tree. Let's do another one. We can do this one in green. Right, so just write down a random statement of propositions. Okay, so there's my argument, and again, I start by negating the conclusion. Now when I'm doing these trees, I'm always working from the thing with the least brackets outside of it to the thing with the most brackets outside of it. So if I'm looking at this complex proposition down the bottom here, I'm moving from this negation, which has no brackets around it, and that's a negation of this conditional here, so I'm going to do the negated conditional first. That's going to get me another negated conditional. I'm going to do that, and then I'm going to get this negated circle with a hash cross through it, and so I'm going to do that. So again, I'm going to try and focus on doing column rules first. I've actually got a bunch of different column rules here. This here is a column rule because it's the negated circle with a cross through it. This here is also a column rule because it's a negated conditional, and all negated conditionals are column rules. So I'm going to start with this one. I get A, not B, arrow, A, B, like that. That gets me another negated conditional, which is another column rule. I'm going to do that next. B, not A, B, like that. And then the last thing I'm going to do is this negated circle with a cross through it. And that, the next thing I'm going to do is a negated circle with a cross through it. And the rule for that tells me to just write A and B down below it. So when it's negated, then both sides are true, and you just write those down underneath it. All right, so now I've got this column rule up here to do, which is a negated circle with a cross through it, so I'm going to do that. That's going to get me A and B and C. I've got another column rule here, which is the A and B, so I'm going to do that, A, B. Okay, I'm going to just draw an arrow. I do the top rule first, which is also a column rule, because that's a conjunction. And then I'll carry the tree over to that side so you can see it a little bit more clearly. So that's going to be C, and then A, arrow, B, A, like that. Okay? Right, now I'm going to just draw an arrow up to here and finish the tree off over on that side. I've just got this last conditional to do, and that's going to branch. I'm going to get not A, not A on one side. Oh, the whole thing's been deleted. All right, let's do it again. A, arrow, A, B, and C, and then the next premise was not A and B, C, and then the last thing was A, arrow, B, arrow, A, B, like that. Okay, so you get to see me do it again. So I'm going to do it again, but this time I'm going to do it a little bit more quickly so that we can get back to the end. All right. start by negating the conclusion. That gets me A, I do this negated conditional, gets me A arrow, A and then B arrow, circle with a slash through it, AB like that, and then I do B, and I do this conditional here, which gets me B, and then not A, B like that, and then I do that, which gets me A, B. And then I'm going to do this negated circle with a cross through it up here, which gets me A and B and C. I'm going to do the A and the B next, and then I'm going to do that rule up the top, which is a conjunction, A arrow, A, B, like that, C. Then I'm going to continue over here. And now I've got to just break that conditional, which is this last sentence here. I'm going to do that next, so that's going to be a branch. On one side I'm going to get not A, and that not A is going to close with the A above it. Remember, I'm just continuing from this point in the tree. And on the other side, I'm going to have, A, B like that. And then this thing, this circle with a cross through it, that's going to branch, and I'm going to get not A on one side, not B on the other side. And those two will both close because we've got an A and a B further up the tree, and so we can conclude from this that the argument is in fact valid. Okay, so that gives us two. I'll do one more, and the last one that I'll do will be an invalid argument, so we can see how to draw out a conclusion from an invalid argument. Do this one in blue. Okay, so let's A, if and only if not C, therefore B, conclusion not A. Okay, so that's my argument. Now, as before, I've got to negate the conclusion. Even when there's already a negation there, I've got to add another one. So I'm going to do that first. Now what I've got to do is work through the various rules in order to complete the tree. So what I'm going to do first is I'm going to do this double negation because that's easy and that's just means I strip away the two negations to get to that. And now I'm going to do, any of these rules really are as good as any other to do because at this point they're all going to be branching, so I'm going to end up with some kind of branching structure. I'm going to do this one next, so I'm going to branch that. I'm going to get not A on one side, not B on the other side. And then I'm going to do this top rule, this biconditional, and I'm going to have to do that on both sides. So it's going to look like this. Okay, so I look for any closure. This A and this not A here are going to close, so that first branch of the three is going to close. And now I've got to do the rest of the branches. Now I know that the negation of this circle with a cross through it is a column rule. I write down but the things on the two sides of it down one after another, so I'm going to do that. The negation of this cross rule where we've got B and C just gives me B and C, and over here B, C. And that's nice because that closes that branch. So now I've only got two branches to deal with. On one branch, I've got this rule here, the circle with a hash, the cross through it. And then on the other branch, I don't have any other rules to do, so I'd be moving back to that. So I'm going to do this one first. This is a branch. I get not B on one side, not C on the other side. And then to finish off the tree, I do the conditional, which is in the second premise. I've already done that, so I'm going to do this next. And I'm going to have to do it on all three open branches. I got a bunch of double negations to deal with. I'm going to do all of those all at once. Okay, and now I look for anything that closes the tree. I've got a B here and a not B there, so that closes. I've got a not B here and a C here. That's all fine. I've got a C here and a not C here, so that closes. but nothing else closes, and because nothing else closes, the tree is complete and there's at least one branch open, so I know that the argument is invalid. Now what I want to do is I want to read a counterexample off the argument. In order to read a counterexample, I pick one of these open branches and I read the values for the basic propositions and their negations off of that branch. So I'm just going to label each of these branches for us. We've got branch 1 here, branch 2 here, and then branch 3 here. Get rid of this branch, get rid of that number. And then branch 4 here. Right, and now I'm gonna read off all 4 of the counterexamples so that we can see how it works. We've got 1, 2, 3, 4. So the basic idea is when I see a proposition on its own, I assign true to that proposition. When I see a negation, I assign false to that proposition. So if I read off this first branch, I've got C equals T because I've got C being true. I've got B equals T, and I've got A equals F. If I read off this second branch, I've got C equals T, I've got B equals F, and I've got A equals T. All right. The third branch, I've got B equals F, and A equals T, and C doesn't take a value, which means that C can be either true or false, so I'm just going to set it to T. You can equally have it set to false. When it doesn't appear on a branch, that means that its value can be either true or false. And then the last branch, I've got B equals F, C equals F, and then A equals T. All right. Now, I'm going to look to see if I've got any doubles, any sort of counterexamples that provide the same information. And if I look through, I've got C equals T, B equals T, A equals F, C equals T, B equals F, A equals T. The first two are distinct to each other. B equals F, A equals T, C equals T. That is the same as 2, so 2 and 3 are the same in this case. And then B equals F, C equals F, A equals T. That is distinct to any of the others. So 1, 2, and 4 are all distinct, and then 3 is the same as 2. If I set C to be F in 3, then it would be the same as 4. So we've actually only got 3 distinct counterexamples that we can draw out from this tree. Any of these would provide a counterexample to the argument, so it would be a situation, if you put in those values for your basic proposition, so you set A to be F and B to be T and C to be T, and then you did the truth table, or you worked through the truth table for the relevant argument, then you would see that the premises are true and the conclusion is false for any of these 4 situations. Okay, and that's it. That gives you a sense of how to approach these questions when you've got these new connectives. Bottom line is nothing's really changing. You've just got to make sure you incorporate these new rules into the truth trees that you're working through. Why am I giving you these new rules? I'm giving you these new rules so that you sort of take a step back and think a little bit more deeply about how it is that the truth tree system is actually working, how it is that you can make that system flexible so that if you do want to include new sort of connectives in your language, then you can build a truth tree system that reflects that. And it's also to just give you a little bit more practice working with some more unfamiliar concepts that can help you to expand your range of understanding and to give you experience working with aspects of the logic that aren't immediately familiar to you. Okay, until next time, thank you very much.